Okay, let's dive right in. Back in 2020, a single research paper landed that didn't just nudge the world of artificial intelligence forward, it pretty much changed the entire game. We are, of course, talking about the paper that gave us GPT-3. And it all kicked off with this one kind of radical question.
What if, instead of spending weeks and weeks retraining a giant AI for every little new task, you could just show it what to do, and poof, it gets it? You know, that was the big dream for a long, long time. And for years, that's all it was, a dream. Because, well, the way we used to teach an AI was a whole different ballgame.
So before GPT-3 came along, teaching an AI was powerful, yeah, but man, was it slow. Let's take a look at what I mean by the old way.
Okay, so the main method back then was something called fine-tuning. And the idea was actually pretty straightforward. You'd start with a huge general-purpose AI model, one that's already learned from like the whole internet. Then you'd specialize it. You'd actually have to go in and retrain its core programming, these things called weights, by feeding it thousands, and I mean thousands, of very specific examples for the one single thing you wanted it to do. And believe me, they called it a grind for a reason. Just look at these steps. For every single new thing you wanted the AI to learn, I don't care if it's translating French or answering trivia questions or writing a summary, you had to start all over again. You'd have to go out, collect a whole new set of data, spin up the supercomputers, and basically perform brain surgery on the model. I mean, yeah, it worked, but it was just so impractical.
This analogy here really hits the nail on the head. Think about it. It's like you have a master chef, right? Someone who can cook almost anything. But with this old fine-tuning method, if you wanted to teach them how to make just one new dish, say a perfect beef Wellington, you'd have to send them back to culinary school for a whole year. And then, guess what? If you wanted them to learn to make ramen, that's another year of school. It doesn't scale at all. It's crazy when you think about it like that.
All right, so this is where things get interesting. The researchers behind this paper, they decided to make a really radical bet. They looked at this whole fine-tuning grind and thought, there has to be another way. And their idea basically went against everything the experts thought was true at the time.
They asked a simple question. What if the answer wasn't some clever new training technique? What if we just made the model bigger? Like so ridiculously, unimaginably massive that new skills just started to appear on their own.
And when I say massive, I mean, look at that number. 175 billion parameters. To put that in perspective, that was more than 10 times bigger than any model of its kind that had ever been built. This wasn't just a small step up, it was a giant, stratospheric leap into, well, nobody really knew what.
And you know what? The bet paid off. Big time. This quote right here, from the very beginning of the paper, it's basically the bombshell finding. They're saying, hey, we showed that just by making these models huge, they get really, really good at learning new things on the fly without any of that old school fine-tuning.
And this new ability that just kind of appeared out of nowhere, they gave it a name, few-shot learning. This was a totally new paradigm, a new way for an AI to pick up skills, not by rewiring its brain, but by learning in real time, right in the context of a conversation.
I mean, just look at the difference here. It's night and day. On the left, you've got the old way, fine-tuning, you need thousands of examples, tons of computer time, all that work. But on the right, the new way, few-shot learning. All you do is give the model a handful of examples, a few shots, right in the prompt. And it just gets it. It figures out the pattern instantly.
So you might be wondering, what does this actually look like? Well, it's almost ridiculously simple. Let's say, for example, you want to get GPT-3 to translate English into French for you. Instead of creating a whole new data set, you just talk to it. You write a prompt. You just give it a couple of examples to get it started. You show it, okay, sea otter in French is loutre de mer. Peppermint is menthe poivrée. See? You're just setting up a simple pattern for it to follow. And then, this is the magic part. You just give it the word you actually want to know, like cheese, and you just let it finish the sentence. That's it. That's the whole thing. No retraining, no changing its brain. You just showed it what to do, and it learned right there, in that moment. This was the revolution.
But of course, with great power comes, well, this incredible new capability wasn't all good news. The results were amazing, for sure, but they also uncovered some really troubling stuff.
Okay, so what are these charts telling us? Well, they're basically the proof in the pudding. The chart on the left, it shows exactly what the researchers bet on.
As the model gets bigger, as you go from a few million parameters all the way up to 175 billion, its performance just keeps getting better and better. And the one on the right shows that the more examples you give it in the prompt, the smarter it gets. So it's a simple formula. Bigger model plus more examples equals way more power. And this table here, this really drives home just how nuts this was. So there was this other really good model called T5. It was heavily fine-tuned just to answer trivia questions, and it got about a 60% score. Pretty good, right? Well, GPT-3, using just that simple few-shot trick we just talked about, came in and scored over 71%. It completely crushed the specialist model without even breaking a sweat.
But like I said, this immense power, it came with a real dark side. As the researchers kept digging into what this thing could do, they realized that its knack for mimicking human writing, well, it came with some serious baggage attached.
So check this out. This is pretty wild. The researchers ran an experiment. Could regular people tell the difference between a real news article and one that was secretly written by GPT-3? And this chart shows the scary result. As the model got bigger and better, our ability to tell what was real and what was fake just nosedived. By the time they got to the full-size GPT-3, people were only right 52% of the time. That's literally a coin flip. The AI had gotten so good, we couldn't tell it apart from a human.
And here's the other big problem. The model didn't just learn our language and our writing styles. Because it was trained on a huge chunk of the internet, it also learned all of our stuff. It absorbed all the patterns, all the associations, and yes, all of the ugly societal biases that are baked into that data.
This graph from the paper is a perfect and pretty disturbing example. What they did was measure the sentiment, how positive or negative the language was, when the AI wrote about different racial groups. And they found these really clear, troubling patterns. For instance, text it generated using the term black almost always had a more negative sentiment. The AI wasn't being malicious, it was just perfectly reflecting the biases it found in all the text it learned from.
And it wasn't just about race. The paper documented all sorts of biases it had picked up. It learned gender stereotypes, right? So it would associate jobs like professor with men and nurse with women. It picked up on religious biases too, linking words like terrorism way more often with Islam than with any other religion. At the end of the day, the model was just a mirror held up to the internet, reflecting everything back at us, warts and all.
And so that really brings us to the final and maybe the most important takeaway from this whole thing. The GPT-3 paper wasn't just a story about a cool new AI that could learn instantly. It was a wake-up call. It proved that when you train a model on the vastness of human language, it doesn't just learn our knowledge and creativity, it also learns our flaws and our prejudices. Which leaves us with a pretty heavy question to think about. When we build an AI that learns from us, what do its flaws reveal about us?